Good day everyone. In this video I'll be talking about measurable sets, the Sigma algebra Lebesgue measurable sets. But I'll look at measurable sets. Let us define and know the meaning of measurable sets. When is a set said to be measurable, or define a measurable set? Okay. When we say measurable sets, a set is said to be, or let's just define measurable set. Measurable set, amen. Measurable set, measurable set. Let's give the definition. Then we are going to look at one example, as simple as ABC. Amen. Okay. Look at it. Let E be a measurable set provided for any set A. Amen. Any set A, that is outer measure of A is equals to outer measure of A intercept E plus outer measure of A intercept E complement. Amen. This is complement, A complement. So this is the definition for measurable set. Excuse me. So whenever you are asked to define measurable set, you can give this definition mathematically, or if you are asked when is a set said to be measurable, you now say a set is said to be measurable if and only if provided for any set A, outer measure of A is equals to outer measure of A intercept E plus outer measure of A intercept E complement. That is simple definition. Okay, now we want to make use of this to solve example. Let's look at one example. Example. Amen. Is simple as ABC. Show that outer measure of A union B is equals to outer measure of A union B intercept E plus outer measure of A union B intercept E complement. It's simple as ABC. I'm going to show you how to prove this. It's not difficult, so I'm going to show you. Is that clear? Okay, let's write solution. Solution. Our outer measure of A union B is equals to outer measure of A union B close bracket intercept E plus outer measure of A union B close bracket intercept E complement. Amen. Okay. Now we are going to, if A is disjoint from distributive law, we are going to apply distributive law here. By applying distributive law, is simple as ABC. Distributive law, amen. By distributive law, if you can see what I am saying, let us just consider only the right hand side. It means by distributive law, This implies that this is the same thing as outer measure of A, all in bracket, A intercept E union B intercept E. Okay, let's do it this way. It implies that this is the same thing as this. Then likewise, plus outer measure of A intercept E complement union B intercept E complement. It implies that this is the same thing as this. Are you seeing what I am saying? Go back to your set theorem. Okay, we are using set theorem here. Okay, so if you agree with me, go back to set theorem. What do we have here? We have union here. We also have union here. It implies that we can replace this with plus. True or false? But mind you, we have outer measure here, so it will affect both. So if we replace it with plus, it means this is how it will look like. A intercept E close bracket plus B intercept E plus the same thing applicable here. A intercept E, amen, sorry, complements, plus instead of U we use plus to replace U, plus B intercept E complements, close the bracket. So if you can see what I am saying, we have to multiply out the bracket. If we multiply out the bracket, we discover that this is how we are going to use this outer measure to multiply out the bracket. If you agree with me, this is how it will behave. Mind you, we are just talking about the the right hand side. So now our outer measure of A union B will now be equal to multiply out this. Give us outer measure, amen, of A intercept E plus outer measure of B intercept E. What do we have here? Plus the same thing applicable here. Outer measure of A intercept E complement plus outer measure, because we are using this outer measure to multiply out this bracket. So this is what we are going to have. Outer measure of B intercept E complement. Amen. Do you agree with me? Okay. Do you agree with me? Can I clean this up so that if you can see what I am saying, look at it very well. Are you seeing what I am saying? Look at it. If you can see what I am saying, it means we can collect like terms, this and this, this and this, true or false. So our outer measure of A union B is now equals to outer measure of A intercept E plus outer measure of A intercept E complements plus outer measure of B intercept E, amen, and plus outer measure of B intercept E complements, amen. Okay, so if you can see what I am saying, look at it. A measurable set is of this form, true or false. Now we have two variables. We are talking about A and B, isn't it? True or false? Look at A. A. Look at it. So now a measurable set of A is equals to this. Look at it here. Then it implies that a measurable set of B is going to be of this form. Look at it. Let's note that a measurable set of B is equals to outer measure of B intercept E plus outer measure of B intercept E complement. Are you seeing the logic here? Amen? So now, the whole of this thing will now turn to this, because this gives us outer measure of A, then this gives us outer measure of what? B. Look at it. So this implies that this is outer measure of A, the whole of this. Then the whole of this implies that outer measure of what? B. So therefore, if you can see what I am saying, amen? If you can see what I am saying, this implies that our outer measure of A union B is equals to outer measure of A plus outer measure of B. This is how you are going to prove it. Is it difficult? Any question? Please make sure you share this video. I know very well that students find it difficult in pure mathematics. Please make sure you try and help somebody. Make sure you subscribe also. Thank you and God bless you.